So to do an example like number 2, it helps to get a picture. If we just read the instructions again, it says use the given values to evaluate all 6 trig functions. So when it says all 6 trig functions, what this is saying is, we have the tangent, we have the cosine, so go ahead and get sine and cosecant, cotangent, etc. So if the tangent of the function is positive, first of all, so it's helpful to understand that this is positive and the cosine is negative. So when you do a quick little evaluation of where this one is going to be, you know that if tangent is positive, that you are going to have to either be here or here, and you know that if cosine is negative, then that means you're either going to be here or here. And so the only place that I highlighted twice was down here in the third quadrant. So we know that the triangle that we're going to draw to model this is going to be down in the third quadrant. So we can draw this a little bit bigger. And again, you know that there's going to be some sort of triangle down here. We've got our right angle. It says cosine, just as an example, is negative root 3 over 2. So here's your adjacent, negative root 3. Here's your hypotenuse of 2. Now this looks like a 30, 60, 90 triangle, right, where your 30 is here and your 60 is here. So let's go ahead and put our negative 1 down there. Now again, the reason we know this is negative is because it's down below the x-axis here. And so this one is negative because, again, it's to the left. We know that our hypotenuse is always going to be positive. So let's go ahead and evaluate the other trig functions. So we need to not only find the sine of x, we also need to find, we already got cosine and tangent, which means we're also going to need to find cosecant of x. We already know cosine, so we're going to do secant of x, and then we're going to have to do cotangent of x. Now, for sine of x, we're just going to do opposite over hypotenuse, right? Negative 1 over 2. So sine, we're looking at opposite and hypotenuse, so that should be pretty easy. Negative 1/2. Cosecant of x, we're just going to flip that, so that's going to be 2 over negative 1, which is negative 2. For secant, we should be able to go ahead and flip cosine over here. So you shouldn't have to go and evaluate. If you want to look at the triangle, you can. Secant is hypotenuse over adjacent, so it's going to be the same thing, 2 over negative root 3. So when you have 2 over negative root 3, we're just going to rationalize the denominator. So remember to do that, we're going to multiply the top and the bottom by root 3. So you end up with 2 root 3 over root 3 times root 3, which is just 3. And we have a negative here, so we'll have that. And then cotangent, again, just to show, you can flip tangent and just use the reciprocal. So we should be able to do 3 over root 3. So that'll be 3 over square root of 3. Again, we're going to multiply the top and the bottom by the square root of 3 in order to rationalize the denominator. And then that gives us 3 root 3 over 3. 3's cancel, and you just end up with the square root of 3. So just to highlight our answers so that we're comfortable here, for cosecant of x, it's negative root 2. For secant of x, it's negative 2 root 3 over 3. Cotan of x, didn't write my x, is going to be just root 3, and then the sine of x is negative 1/2. So that's how to do an example like number 2. So why don't we look at some that maybe aren't, maybe not special right triangles, or just look a little bit different. So we'll go ahead and get rid of this. Oops. And move on to the next one. Sorry. So we could look at something like 4. That's going to give us a similar question. Now, maybe what we'll do is try and take a couple shortcuts here and do it as efficiently as possible. So if we already know cosecant, that means, remember that sine is 1 over cosecant. So if I know that cosecant of theta is 5 over 13, that means that the sine of theta is going to be 13 over 5. If we know that the tan of theta is equal to 3 over 4, that means the cotan of theta is equal to 4 over 3. So the only one that we can't necessarily get just by looking at these is sine, is cosine. Now you might be able to figure this out, right? Tangent is opposite over adjacent. So, you know what I mean? Or sorry, yeah, tangent is opposite over adjacent. So you should be able to, infer that the adjacent side is 4, and then also if you know that the, I just wrote 5 over 3. Sorry, I'm just going to fix this here. That was 3, not 13. Okay, so what you should be able to do is, also look at sine opposite over hypotenuse, which means we should be able to find cosine without even drawing this, right? Cosine of theta is adjacent, which is 4 from right here, over hypotenuse, which is 5 from our sine over there. So we've got our cosine, and then you could also find secant just by finding the reciprocal of cosine. So that's going to be 5 over 4. So you don't have to draw the examples, but you can if you want to make it a little bit easier. So, okay, let's look at a couple other examples. I'm going to erase our stuff here. And maybe let's look at, we've got an example like 6 or 8. I'm not really going to look at ones with the shifts here, but let's look at, we'll skip something like 6 and go up to 10, maybe that one. So we know that the secant of x is going to equal 4. And we know that the sine of x is greater than 0. So again, just like the first question, it's helpful to use our all students take calculus and figure out where this is. So if the secant here is positive, remember that secant is 1 over cosine. So just, while we're here, we can find that the cosine of x is 1 over 4 just by finding the reciprocal. Now keep in mind that's positive. So the cosine is positive here and here. And your sine, it tells us, is greater than 0, right there. So the sine is greater than 0 here and here, which means we know that our angle is going to be up there in the first quadrant. So if you wanted to draw this out, make a right triangle. We already know that cosine is 1 over 4, so I guess maybe just to make this a little bit more accurate, adjacent over hypotenuse, and we could find our third side just by using the Pythagorean theorem. So if you just do a quick, 1 squared plus b squared is equal to 4 squared. 4 squared is 16 minus 1, so b is going to be the square root of 15. So by having that, you should be able to find your other trig function. So we'll just do a quick, sine x is going to be opposite over hypotenuse. That means that the cosecant of x is going to be 4 over root 15. Again, we're going to rationalize the denominator, so we'll just multiply the top and the bottom by the square root of 15. So that's 4 square roots of 15 over 15 for cosecant. So we've got, just to check what we've got for our answers here, we've got secant, we've got cosine, we've got cosecant, we've got sine, so we're just waiting on tangent and cotangent. So tangent of x is going to be opposite over adjacent, so that's root 15 over 1, which is just the square root of 15. Cotan of x should be the reciprocal of that, which is just 1 over square root of 15. Again, we're going to rationalize the denominator. Just like to do that in different colors. So root 15, and you end up with the square root of 15 over 15. So that means tan of x, we've got our answer, cotan of x. So we've got all 6. So that's an example of how you can do something like number 10. So the last one I'll do is, well, 12 is going to be similar. So actually we'll just end it there at 10.